Hi, in this video, we are going to see about FCFS scheduling algorithm with different arrival time. So in the previous video, we saw about how the FCFS scheduling algorithm works with zero arrival time. When all the process has the same arrival time, like zero arrival time, how that FCFS scheduling algorithm works, we saw it in the previous video. So in today's video, we are just going to see the same algorithm with different arrival time. So we will see how that particular algorithm works with different arrival time. So here they have given the process IDs and then arrival time they have given for each and every process and the burst time for each and every process. So once this is given, the first thing which we need to do is the construction of the Gantt chart. Okay, so we are just going to see construct the Gantt chart. So how we will do it? So we have 5 process. So you need to see which process will get in first. Okay. So your process P1 arrives at time 0. So P1 will come in first and it goes till 3 milliseconds. So 0 to 3. And after that your P2 comes in. So P2 will go up to 6 millisecond. So it is 3 plus 6. That means it is 9. Okay, that means it is 9. So in this 9th millisecond, if you see, already your process P3 and P4 are already available in the ready queue. Okay, so at this point of time, both the process are waiting in the ready queue. So now the CPU scheduler needs to decide which process has to be given to the CPU for execution. So in this, it will see which is having the less arrival time. So as you know, your P3 is having the less arrival time. That means P3 has arrived first and after that your P4 has arrived. So now your P3 will be given to the CPU for execution. So P3 will arrive next and it is going till how many milliseconds? It is going till 4 milliseconds. So 9 plus 4, it is 13 milliseconds. And this point of time, at this point of time, your P4 and P5 is already there in the ready queue. So once again, the CPU scheduler will decide which has to be sent to the CPU. So in this, your P4 is having the less arrival time. That means P4 arrived first. So P4 will be given to your CPU for execution. The next process to go in is P4. So P4 is executing till 5 milliseconds. That means 13 plus 5. 18th millisecond, your P4 is getting over. And finally, your P5 will come. It is executing for 2 milliseconds. That means 18 plus 2, it is 20 milliseconds. Okay. So now the Gantt chart is ready. So once the Gantt chart is ready, the next thing which you need to find is the completion time of each and every process. This completion time you can find it from the Gantt chart itself. So the first process, when does it get completed? So it gets completed at 3rd millisecond. So that is 3. And your P2 gets completed at 9th millisecond and P3 gets completed at 13th millisecond and then your P4 gets completed at 18th millisecond and P5 gets completed at 20th millisecond. So I got all the completion time of each and every process. Once this is over, I need to find the turnaround time. Okay, you need to find the turnaround time. So as you know, how to in the previous video we saw how to find the turnaround time. Okay, we can't directly go and find out the turnaround time. So for that we have a simple formula. Turnaround time is equal to completion time minus the arrival time. Okay, already in this particular table we have the completion time and arrival time. So just subtract these two, you'll be getting the turnaround time. So 3 minus 0, it is 3. 9 minus 3, 6. 13 minus 6, it is 7. And then 18 minus 9, 9. And then 20 minus 12, it is 8. Okay, so turnaround time we have found out. Once the turnaround time is over, we need to find out the waiting time for each and every process. So as you know, waiting time, we can't find it directly. So for that also we have a simple formula. Waiting time is equal to turnaround time minus the burst time. So right now we have the turnaround time and we have the burst time. So we can able to find out the waiting time. So here you see 3 minus 3 for burst for the waiting time of process P1 is 0. 3 minus 3, it is 0. So why it is 0? When process P1 comes in, the CPU was already free. Okay, the CPU was already free, so it has been given to the process P1 immediately. That's why P1 didn't wait for the CPU. That's why it is 0. And once again, you see 6 minus 6. Okay, the next process is 6 minus 6. Once again, it is 0. Waiting time of process P2 is 0. Why it is 0? Your P1 gets completed at third millisecond. At the same time, the process P2 also enters the ready queue, and P1 has completed its execution on third millisecond. So immediately P2 has been given the CPU. Okay, P2 didn't wait for the CPU. So immediately it has been given the CPU. That's why it is 0. So for P3, 7 minus 4. 7 minus 4, it is 3, and then 9 minus 5, it is 4, 8 minus 2, it is 6. So I found out all the waiting time. So once this is done, I need to find out the average turnaround time. Okay, average turnaround time. So how you will find out? You have the you have the turnaround time for each and every process. So add everything, divide by the total number of process. So 3 plus 6 plus 7 plus 9 plus 8 divided by the total number of process. Here the total number of process is 5. So when you add everything and divide by 5, you will be getting 6.6 milliseconds. That means average turnaround time per process is 6.6 milliseconds. And the next thing which you need to find out is the average waiting time. So you have the waiting time for each and every process. Same way you have to add each and every waiting um, time and divide by the total number of process. So how you will do? 0 plus 0 plus 3 plus 4 plus 6 divide by 5. So it will be 2.6 milliseconds. Okay, so the average waiting time per process is 2.6 milliseconds. Okay, so this is how your FCFS scheduling algorithm works with different arrival time. So in the next video, we'll be seeing about how the same FCFS scheduling algorithm works with different arrival time, and it will be having some idle CPU sessions. Okay, idle CPU sessions it will be having. That we'll be seeing it in the next video. Thank you.